Let's look at a couple more examples. This next one has a fraction in it, but I'm still going to follow the same format that I used in problem 5. I'll allow x to equal 0 the first time through, so I have y equals a negative 1/2 times 0 plus 3, and since negative 1/2 times 0 is 0, y is just equal to 3. Now I'm going to let y equal 0, so I have 0 equals a negative 1/2 x plus 3. I'll subtract 3 from both sides, giving me negative 3 equals a negative 1/2 x. And if you remember back to our first unit, to get rid of that negative 1/2, I'm going to multiply by the reciprocal, which is a negative 2/1. This will get rid of the 2, the 1, and the negative, leaving me with just the x. So when I multiply this other side by a negative 2/1, I get a positive 6. So when y was equal to 0, x was equal to 6, giving us the ordered pair 6, 0. Then I'm going to check one more point, and in this case, rather than choosing 1, as I did over here, I'm going to choose 2 for x because of this 2 in the denominator. By multiplying by 2, I can get rid of that fraction very quickly. So I'm going to allow x to equal 2. That gives me y equals a negative 1/2 times 2 plus 3, or y is equal to negative 1 plus 3, which means y is equal to 2, giving me an ordered pair 2, 2. Now I'm going to take each of these 3 points and plot them over here on my graph. So x equaling 0 and y equaling 3 is going to be right there. X equaling 6 comes out here just off the edge of my graph. And y equaling 0. And then in the middle I have the point 2, 2. Connecting these with my straight edge. Maybe. There we go. I end up with the following line. Let's try another example. Starting again, the equation x plus y equals 0. If I let x equal 0, I'm going to find that y also equals 0. So this is kind of a special case where the x-intercept and the y-intercept are the same, both happening at the point that we refer to as the origin, right here on our graph. So finding the x and y intercepts only gave me 1 point, which means I need to test at least 2 more points in order to be able to create my line. So without any fractions or negatives in here, really any number is going to be easy to solve. I'll start with a 2 first in the x. If I make the x a 2, I find that y is equal to negative 2. And if I let the y equal 3, I find that x equals a negative 3. So graphing those points on my graph, I'll come over here and graph. I already graphed the origin here at 0, 0. The next point at 2, negative 2 is going to be down here. And the point negative 3, 3 will be up here. So connecting those points together, makes the following line. What if we have an example like this, when you're only given one letter in your equation, just the equation x equals 3? Well, remember back to this first discussion, if I can find that page, when we talked about what the different forms are that a linear equation can show itself in. I'm not finding the page. Where'd it go? The ordered pairs. Truly gone. Okay. That when we have this basic form, the ax plus by equals c, one of them was allowed to be equal to 0 as long as the other one wasn't, between a and b. So we could write this equation as there being a 1 in front of the x, that invisible 1 that shows up in front of our coefficients. And if we let b be 0, we would have 0 y's equaling 3. So even though this equation has only one variable in it, it's still a linear equation. It just has a value of 0 in place of that b. So what that tells us is that x is always going to be equal to 3, and that no matter what value we choose for y, since that value is getting multiplied by 0, it's going to go away. So if y were equal to negative 1, or to 2, or to 5, the x is still going to be 3. So we'll write each of these ordered pairs. And graph our line. Here's x equaling 3. We can have our y equal a negative 1, a positive 2, a positive 5, any of the numbers along those lines, along that line. So the graph of our equation ends up being a vertical line. This situation can also occur where it's the x term that has disappeared. So we could rewrite this equation as 0 x's plus 1 y is equal to a negative 1. Or what it's telling us is that no matter what values you put in there for x, since they're going to get multiplied by 0, the y is still going to equal a negative 1. So we'll try those same points again. What if we put in negative 1 or 2 or 5, multiplying each of those by 0, we still get y equals negative 1. So our ordered pairs are going to be these. Negative 1, 2, negative 1, and 5, negative 1. And when we go to graph these, the point negative 1 is right here. The point 2, negative 1 lies right here. And the point 5, negative 1 is up here, creating, when we graph it, a horizontal line.